Assalamu alaikum and welcome to lecture number 5 of Requirements Engineering, CSC305. And in today's lecture we are going to continue our discussion on Requirements Engineering Process Tasks. Let's quickly recap what we have done in the previous lecture. So let's recap what we have done in our previous lecture. We started with we continued with our discussion on requirement engineering sub-processes. We have so far covered inception, elicitation, elaboration and negotiation tasks. So let's quickly recap what's in these tasks specifically. So in inception we said we basically asked a set of questions, and the idea is to get a feeling about what the customer wants, what are the objectives of the customer, and we try to identify the key stakeholders, and we also try to establish the effectiveness of the communication process with the client. Next up is the elicitation task, and in the elicitation task we try to get something from the customer. We try to ask, or we try to identify the boundaries of our system, and when we try to do so there are different ways of eliciting requirements from the client, and we briefly talked about two different techniques. One of them was collaborative requirement gathering and the other was quality function deployment. Collaborative requirement gathering is one of the most used technique and is one of the oldest technique. The idea behind collaborative requirement gathering is that you try to resolve conflicts when lots of stakeholders are sitting together, and there can be different ways of conducting collaborative requirement gathering sessions. You can have meetings in a big meeting room, you can have virtual meetings, you can have lots of people sitting together in a chat room. But one thing that is important when you conduct such sessions is that you need a recording mechanism. So if it's a virtual environment, then you automatically have a recording mechanism. Whereas if people are sitting together in a big meeting room, then you might want to record all the suggestions of different stakeholders on a whiteboard or maybe on the post-its. Similarly, we also discussed very briefly what quality function deployment is, and we said that it's another elicitation technique. Mainly it is used in engineering discipline, but it can also be used to elicit software requirements as well. So what we try to do is we try to identify customer requirements or customer wishes, and we also try to identify the technical features which the client wants, and we try to map those wishes on those technical features, and we also try to prioritize which wishes are more important for us and which technical features we want to give more priority to. And another interesting thing about quality function deployment is that you can also prioritize those technical features, you can also rank those technical features, and you can do a competitor analysis as well. So for example, you have a competitor out there and you're making a product and you want to evaluate where does your competitor or where does your different competitors stand on a technical feature. And obviously when you're developing something, maybe you want to give a certain more importance to a certain technical feature, and then the development effort would be estimated accordingly. For example, if you want a technical feature more strongly, then more effort would be put on that in comparison to the other technical feature. So that was elicitation, and then we moved on to elaboration or the analysis task of requirements engineering process. So as the name suggests, elaboration is elaborating on what you have already gathered from the client. And we talked about that when we say that we want to elaborate requirements, then there are different kinds of modeling that we can do to understand and analyze the requirements that we have gathered in the elicitation stage. So we discussed that there are 4 different kind of modelings that we can do. One was scenario-based modeling, and when we talk about scenario-based modeling, then we can make use case diagrams, we can make activity diagrams in it. Similarly, we can do class-based modeling, where we identify the domain classes, we identify their attributes, and we also try to identify relationships between different classes. Then the third kind of modeling that we can do is behavioral modeling, where we can make state diagrams which would try to indicate that how and when different classes move from one state to the other state. And the fourth kind of modeling was flow-oriented modeling, where we try to identify what kind of data is flowing from our system, what are the input data and how it is transformed into the output data. And in that process we also try to identify different functions which transform data from the input to the output. And one of the interesting or very important things that we discovered in our discussion when we were discussing the elaboration task was that that amount of analysis that we put into making these models, it the more we spend time in analysis, the more understanding we gain about the product. So it just depends what kind of system we are making. If the system is too complex and requirements are not clear, and this is kind of a software that you're making for the first time, then maybe you want to invest more time in it because you want to gain better understanding of the software that you're going to make. And we saw a particular use case example, and we looked at two use case examples. One was a use case diagram, and the other one was use case text. And as we said, that writing a use case text is more difficult and is more trickier than making a use case diagram. And we clearly saw that when we invested more time in writing a use case, we gained deeper understanding into how a user would interact, which steps a user would take to actually go through that particular user scenario. So not only we identify those small steps, we also identify what are the possible variations that a user might do, what are the exceptions that may occur during these use cases, and if there are any open scenarios, we were also able to identify them. So elaboration is interesting. And another interesting thing that we always say, or you must have heard a number of times, that requirements engineering is the bridge between analysis and the design stage. Why we say that, and I said it in my last lecture, that elaboration is the task in particular of requirements engineering process which actually bridges analysis with design, because lots of these modeling that we do, it basically is a step towards software design. Next we started talking about the negotiation task, or the negotiation sub-process, and in today's lecture we'll start our discussion with the negotiation process, and then we will move on to the other sub-processes or the other tasks of the requirement engineering process. We'll talk about specification, we'll talk about validation, and we'll also talk about requirements management. Briefly, we have already talked about specification, or in detail, in fact, we have talked about how requirements are documented. When we saw a IEEE template, we also saw a particular example of specifying requirements, but we'll also quickly skim through it, that when it is part of this requirements engineering process, then what does the specification process or specification task demands. And we will also talk about validation. What does validation mean, how it is carried out, and what are the steps involved in validating requirements. And finally, one of very important and very interesting process or task of requirement engineering process is requirements management, and which is concerned with the overall requirement engineering life cycle, or requirement engineering process life cycle. That how do we manage requirements, how do we write requirements, how do we manage changes in requirements, how do we trace requirements. These are the things that we are going to discuss in requirements management. So let's start our discussion with the negotiation task of requirement engineering process. And as I said, that negotiation is basically about 4 or 5 things, and one of the most important goals of negotiation is reconciling requirements, reconciling the conflicts between what the customer wants and what can be achieved given the limited time and resources. So for example, customer may want his product to be awesome and his product to have everything. For example, you have a client and he says, no, okay, I want an ERP system which should be custom built for me. Okay. Now, as I said in one of our lectures, that ERPs or enterprise resource planning softwares, they are so huge that normally they are not implemented, they are customized. So you already have a product, and according to your client, you basically change it or customize it. And your client is not willing to pay the amount, or he doesn't have the time. So when we talk about resources, one of the resources is time and the other is the money. So for example, he doesn't have, for example, 5 or 6 years to implement a whole ERP system. And similarly, he doesn't have the budget to actually get it implemented. So he has some limited resources. So I mean, this is so. In that particular scenario, you have to tell your client that, okay, this is not possible in the amount of time we have, in the amount of budget we have, and all the resources that we have, we cannot do it. So this is just one very extreme example, but you can think about very small things. So for example, your client can ask for features which are not possible to do for within a particular time frame. So you have to reconcile such conflicts with the client. Then another thing which is taken care of in negotiation is ranking of requirements. So you try to prioritize your requirements. And as I said, we will have a separate lecture on requirements prioritization. But let me briefly explain you what requirement prioritization is. That you try to rank your requirements. And this ranking is done not only from the customer's point of view, but from the user's point of view and from all the other stakeholders' point of view. So for example, you have your team, you have your domain experts, you have the client, and you have the users at the client side. So there are 4 different kind of resource stakeholders who are involved in this requirement prioritization, and each one of them have their own objectives. For example, if I, as we talked about this learning management system example so often, so let's say I am a student and I want my features to be automated first. So, I'm saying, okay, no, the requirements related to registration and, they should be implemented first, and all those requirements should be given high priority. And the other user might say, no, my features should be given high priority. But it's not that simple. So there can be conflicts, so you need to resolve these kind of conflicts as well when you're prioritizing requirements. So when you prioritize requirements, you are resolving conflicts. You're saying, no, requirement number 3 is the highest priority, requirement number 1 is second, and requirement number 2 is the lowest priority requirements if you have 3 requirements. So this is a very important task of ranking requirements. Another aspect of ranking requirements is that, for example, you have multiple domain experts in your company, and each one of them has their own objectives. For example, one of them wants to minimize cost, the other one wants to maximize quality, and the third one wants to achieve the overall all the functionalities in minimum amount of time. So these 3 different people might have 3 different prioritization of requirements according to what they think would give highest quality, and what might reduce the cost, and what might reduce the time. So basically you need a mechanism to rank requirements when different people have different opinions about prioritization of requirements. Then another thing which is done in the negotiation stage is that you try to identify the risks, all the risks which are associated with any requirement. For example, you have a requirement, you have a hardware requirement where you say you need to buy a certain kind of server, and one of the risks may be that maybe the product is out of order when we actually need it, or maybe a software requirement says that you will use a certain API, and but later on you figure out that API is no longer supported, so that maybe is a risk. Or for example, you are looking to use any component off the shelf, and you realize, no, that component off the shelf is no longer supported by the people who actually built that. So there can be lots of risks which can be identified, and you basically need to analyze each one of them, and you need to plan for them. And then another thing that is done at the negotiation stage is you try to make rough estimates of the development effort, and you do it because you want to analyze the impact of each requirement on project cost and delivery time, because this gives the client an indication that how costly or how time consuming a certain requirement is. And then using an iterative approach, requirements are eliminated, they're combined or they're modified so that each party achieves some measure of satisfaction. So when we carry out these different negotiation tasks in order, what we are trying to achieve is we are trying to figure out which requirements can be done in minimum amount of time, which requirements have the risks which can be mitigated or which can be clearly handled, which requirements we have clearly prioritized. And so what we try to do, we try to eliminate some requirements, we try to merge some requirements, or we try to combine some requirements, and by doing so we ensure that all the parties involved in this particular software project, they achieve certain amount of satisfaction, and they are satisfied that whatever they are getting is the right thing for everybody. So this is in general the negotiation task. Again, we are going to talk about maybe these things in a lot more detail. As I said, we will have separate lecture on prioritization. We'll try to analyze how do we identify risks. So we are going to talk about these things in more detail in coming lectures, of course. So where we stand right now in this requirement engineering task, we started off with Inception, we have done that, we've done Elicitation, we have done Elaboration, we have done Negotiation. And you can see there is a clear flow, and if these things are done accordingly, then you can imagine that we are at a stage where we can start documenting requirements now. Because we went off with Inception, then we asked particular requirements, then we analyzed them, and after analysis, because we had a deeper understanding, we went for negotiation. And after negotiation, when we have actually figured out which are requirements we can do in limited amount of time, and everybody is happy with it, we can then document those requirements. So the next logical step is specifying requirements. So let's quickly see how do we specify, or what do we do when we in the specification tasks of requirement engineering process. Okay, so what is specification? Specification is the final work product produced by the requirement engineer. So when we say software requirement specification document or SRS document, then that is the work product of the overall requirement engineering, that is one of the work products which is being produced by a requirement engineer, or this is one of the work products out of this requirement engineering process. And it is normally in the form of software requirement specification. It serves as the foundation for subsequent software engineering activities. And as we have already seen how a requirement document is written, so you can see that that is a formal product that we get out of this process. And the way requirements are expressed, they are basically, and we said that a requirement document when produced, there are multiple users of a requirements document. So a requirement document is used by the client, it is used by the project manager, it is used by system developers, it is used by system designers, it is used by system testers, it is also used by the maintenance guys. So basically the document that you produce, it is a foundation for rest of the software engineering activities which are to be followed in the software development lifecycle. So it is very important. It's one of the most important document that is produced in a software development lifecycle. It describes the function and performance of a computer-based system and the constraints that will govern its development. If you guys remember, as we defined a requirement as a service or a constraint on the system. So when we are saying that an SRS document, it defines all the functions and the constraints that are put on the system. So it clearly shows that, and it also tells us what are the performance related issues with that particular software. And as you guys remember, that in the section of non-functional requirements, there are different kinds of non-functional requirements that we associate with the particular software. For example, we had performance requirements, we had reliability requirements, we had safety requirements. So all those things are mentioned in an SRS document. It formalizes the informational, functional and behavioral requirements of the proposed system in both a graphical and textual format. And as we said, that requirements are normally expressed in text, but you can also support them with multiple kind of diagrams. For example, you can make usage scenarios in the form of use cases. What are the typical contents of a software requirement specification document? So that's kind of a revision. We have already gone through it to some extent. We have required states and modes, software requirement grouped by capabilities, that is functions, objects, software external interface requirements, software internal interface requirements, software internal data requirements, and other software requirements, which are safety, security, privacy, environment, hardware, software, communications, quality, personnel, training, logistics, etc. and design and implementation constraints. So a requirement document would have one or more of these things. It would have required states and modes, and normally when you express requirements, if I have not mentioned this already, then one of the guidelines of writing a SRS document is, or software requirement specification document is, that you always try to group similar requirements. So the requirements which are related to a certain functionality, they are grouped together. For example, all the requirement related to the safety or the security features of the software, they should be written together. Similarly, all the requirements related to the performance issues should be written together. So grouping of the requirements is not only related to the constraints to the system, for example, as I mentioned, performance and security, but you can also group the requirements which are services provided by the software. For example, going back to our learning management system example, then all the requirements which are related to the students part of the learning management system, they should be written together. And we said that there are certain advantages of doing so, because you make sure that you're not duplicating any requirement, you're not saying something twice, and you're not writing a particular thing in two different ways. So there are certain advantages of grouping your requirements together. We also try to identify the interfaces with which our software would interact, and a very good example is the use case diagram that you make. For example, when we make a use case diagram, then we try to identify all the external entities which are going to talk to our system. For example, who are the actors, who are the external hardware, and what other softwares our software would be communicating with. Similarly, we also try to identify the internal interfaces. We also try to identify what are the data requirements of our system, and we also express some other requirements as well. And there are few other contents as well. For example, qualification provisions to ensure each requirement has been met, demonstration, test analysis, inspection, etc. and requirement traceability, information on requirement traceability, trace back to the system or subsystem where each requirement applies. So we'll talk about requirement traceability matrix in a bit when we move to requirement management task of requirement engineering process. So let's keep this discussion for that. But these are the general contents of a software requirement specification document. So now we have been up to the specification task of the requirement engineering process. The next up is validation. And as the name suggests, that when we say validation, then we are trying to actually ensure that what we have written is what the client wants. So let's see what are the steps which are taken, or what is this validation task about. So during this validation task, the work products produced as a result of requirements engineering are assessed for quality. The specification is examined to ensure that all the software requirements have been stated unambiguously, inconsistencies, omissions and errors have been detected and corrected, the work products conform to the standards established for the process, the project and the product. So now we have a written document, and we have gone through the negotiation task where we thought that we have resolved all the conflicts, and we are at a stage to specify requirements, and then we specified requirements. We not only specified requirements, we identified all the internal external interfaces, we specified everything related to do with the software. Now we want to ensure that whatever we have written in that SRS document, it is unambiguous. So there shouldn't be any ambiguities in the document. There should not be any errors, any omissions in the document. And the final thing that we check for is that if we have any established standards for the project which maybe can be imposed by the client, then our document is actually meeting all of them. And there are different ways of conducting this validation task, but one of the more formal ways is a formal technical review. And I hope you guys are familiar with this concept of formal technical reviews. If you're not, then you will hear about it in your software quality assurance course. That there are two kinds of reviews which can be conducted. One are informal reviews and other are formal reviews. So the main difference between formal and informal reviews are that informal, as the name suggests, they are informal. So there is no time associated with it. So for example, if I am the project manager and I am the quality assurance manager as well, so I can randomly come and see what you are doing. So I have not set a time for this review, but I will come and see and check where my requirement engineer is with the SRS document, and in what ways he is actually expressing those requirements, and what is the quality of those requirements that he is specifying. Whereas in comparison to an informal review, the formal reviews, they are normally timed. They are longer, and they are conducted in informal sessions. So there would be a guy from the quality assurance department, and there would be the person whose work is to be reviewed, and then there would be a couple of people who are recording the meeting minutes and all those things. And the idea is that you want to ensure and you want to record that what are the problems with this document. Okay? And the main thing that is key in this technical reviews, in these formal technical reviews, is that you're not trying to provide the solutions to the problems. You just try to identify the problems, and you document those issues. And then you set an agenda that when and then you give the task to the guy. And so basically, when we say the formal technical review, then this is of the work product. So there are few guidelines of formal technical reviews which I am sure you will hear in your course on software quality assurance. So normally in a review, the members which are included are software engineers, customers, users, and other stakeholders. And it depends what kind of work product is being reviewed. So when we are talking about formal technical review of an SRS document, then these members are for SRS documents. So you would have software engineers, you would have customer, users, and the stakeholders. So for example, I am the requirement engineer, and and when the formal technical review is to be conducted, then my project manager would invite client, he would invite users, he would invite other stakeholders, and I would be presenting my work. I would be saying, okay, this is the document, and this is requirement number 1, requirement number 2, and these are external interfaces, these are internal interfaces. And by doing so, when I would present my work in front of all those people, it would provide me a mechanism, or it would provide the project manager or the person who is responsible for this requirement engineering process a tool to evaluate the quality of the requirements that have been written. So any inconsistencies, any ambiguities, or any quality issues with my requirement would be identified. So what are normally the questions which can be asked when you are validating requirements? Is each requirement consistent with the overall objective for the system or product? So this is very important, that you want to have requirements in a document which are consistent throughout. So you cannot have requirement which is suggesting something at one point, and at the other end, for example, you cannot have a requirement which actually says that a certain feature is very important, and at the other end you say no, this can be done in another possible way. So you need to be consistent throughout your requirements document, and have all the requirements being specified at the proper level of abstraction. That is, do some requirements provide a level of technical detail that is inappropriate at this stage. One thing which is which we I think already mentioned when we were discussing guidelines of writing or specifying requirement is that when we are writing requirements, we are not trying to identify how we can solve a certain problem. We just try to identify what the client wants. We don't want to express how it will be done. So this is very important, that appropriate detail should be in there. You do not want to put too much detail when you are expressing requirements. So this is very important. Is the requirement really necessary, or does it represent an add-on feature that may not be essential to the objective of the system? So again, you also try to evaluate, when you are evaluating each requirement, you try to ask this question as well, that whether this is an added-on feature or this is something which is really needed for the overall objective of the software. Is each requirement bounded or unambiguous? A very good criteria of determining whether a requirement is bounded or not is actually evaluating whether you have expressed a requirement in a quantitative way or a qualitative way. If you guys remember our bus locator example, the requirement document which I showed you in one of the lectures, one of the examples was that you had to send the GPS location from the driver side application to the server. Okay. Now, if I would have expressed that requirement that in a fashion that send GPS location from driver side application to the server, now that is an ambiguous requirement, because as we talked about that, how often should I be sending this GPS? Should I be sending these GPS coordinates as soon as I get new coordinates? So what should be the frequency? So if you guys remember, then in that requirement document we mentioned that after every 30 seconds the new GPS coordinates would be sent to the server. And there are different rationales that we discussed, that why we said 30 seconds, because there is the only mechanism for sending the data was GPRS at the time. So we wanted to minimize traffic on the network as well, and we thought, okay, 30 seconds won't hurt too much and the bus won't go too far in 30 seconds. So if we have new GPS coordinates with us after every 30 seconds, so it would suffice. So we want to evaluate whether all of my requirements, they are expressed as good quantitative unambiguous statements or not. So does each requirement have attribution, that is a source noted for each requirement? So this is also very important, that who was the requester of a particular requirement. You would want to record that. So again, going back to our bus locator example, if you guys remember, then I think one of the things which I mentioned was that when you are trying to express requirement, then there are a number of different ways in which you can express requirements. So normally I said that the requirements are written as text, but if you remember our bus locator example, then there were multiple things that we were trying to record for each requirement. We were trying to record the identifier, we were trying to record the requirement name and the requirement text. Then we were trying to identify the rationale. We were trying to identify what are the risks associated with each requirement. We were trying to identify dependencies of each requirement, and who is the requester of this requirement, which we were also trying to record that, who asked for this particular feature. Now, why is this important? Because in case of any ambiguity that you find in the requirement, you should know that which is the person you should talk to. If you see that a statement is ambiguous, or if you see that the statement is qualitative or statement is not consistent, then you should go and talk to the person who actually requested that in the first place. So that is why attribution of requirements is very important. And moreover, do any requirements conflict with the other requirements? That is another thing that we need to ask. Is each requirement achievable in the technical environment that will house the system or product? So we also need to evaluate whether a certain feature that is requested, whether it can be done in the given environment or not. For example, a client wants that whenever the resources come in the office in the morning, then an automated attendance mechanism should be there. But he's not willing to invest money in the biometric devices. So how it can be done in that particular environment? So basically, there needs to be proper mechanism to actually do that. So the technical environment should be there. You need to evaluate that whatever feature that the client is requesting, whether it can be done with the technical facilities which are around or in which the system will be housed later on. Is each requirement testable once implemented? So this is also very important, that how you will test this particular feature when you are going to deploy this at the customer site, whether there will be a demonstration, or you will conduct an actual test, or whether you will inspect it, how you are going to actually test this particular requirement. So you need to ensure that all the requirements that you have written, they are testable. Does the requirement model properly reflect the information, function and behavior of the system to be built? So this is a generic thing that you want to achieve in the when you're validating requirements. And has the requirements model been partitioned in a way that exposes progressively more detailed information about the system? So you want to ensure that the requirements are written in a fashion that you are gaining more understanding about the requirements. So for example, you have text, then you have made some diagrams, you have done more analysis. So the information should be presented in a way that it shows that progressively you are gaining understanding about the system. So now we have done the 6 tasks of requirement engineering process. We are up to validation. So we have identified the client, the stakeholders, we have expressed requirements, we have analyzed them, we have negotiated them with the client, we have specified them, and we've also ensured that whatever we have written is of good quality. And now is the final task of requirement engineering process, which is the requirements management. So let's quickly see what requirement management is all about. So requirements management task is that the project team, it performs a set of activities to identify, control and track requirements and changes to the requirements at any time as the project proceeds. So as I said, that if we go back to this diagram of the requirements engineering process, then you can say that, you know, all these 6 steps of requirement engineering process, requirement management is there to support all of them, or requirement management is there to manage all of these small tasks, because requirement management says that you will identify and you will also control and track all the requirements and changes to the requirements at any point throughout the project. So one thing that we realize, that maybe all of these other tasks of the requirement engineering process, they would finish at a certain amount in the project, whereas the requirement management task, it would continue throughout till the project is complete or till the project is delivered to the client. So for example, you can say that, you know, this is the lifeline of your project, where you have time t here, and yes, say this is the beginning date of the project. For example, this is day 0 of the project, and you start your inception here, and you also started your elicitation here, then you move to elaboration, and you also started negotiating the requirements, and then you started specifying the requirements, and you done your validation. Whereas the requirement management task of the requirement engineering process, this is going to go throughout the project until you actually deliver the product to the client, because the requirement management is not only about identifying the requirements, it is also about identifying and controlling changes to the requirements. And if you guys remember, one of the problems with the requirements that we mentioned in a first lecture was that requirements are volatile and requirements are subject to change. And this is a very common phenomenon with software requirements, that client would come back to you and he would want changes in the requirements. So you need a proper mechanism to control those changes, to identify those changes and to analyze those changes, and requirement management is also about that. So now, as a part of requirement management, each requirement is assigned a unique identifier, and this is something that we talked about when we discussed our bus locator example. The requirements are then placed into one or more traceability tables. So you guys, we coined this terminology in one of the previous tasks of requirement engineering process, requirement traceability. So when we talk about requirement traceability matrix or requirement traceability table, you can have multiple tables. Okay. The idea is that you want to trace your requirement throughout the system. You want to trace that requirement through different subsystems, into different test cases, into different design artifacts that you're producing. So what do these tables have? These tables may be stored in a database that relate features, sources, dependencies, subsystems, and the interfaces to the requirements. So you can make a small database where, because you have a table, so you can say, okay, if you want to see requirement 1 can be traced to, for example, subsystem student, and this is tested in test cases 1 to test case 10, and certain class diagrams are also related to it. So for example, you want to see that if there is a change in a particular requirement and you want to evaluate that what is the impact of this particular change, and you want to control the overall change. So if you have not maintained this traceability of a certain requirement through your system, you will not be able to correctly analyze the impact of that change in that particular requirement, and you will not be able to evaluate that change in a fashion that would ensure that you implement that change correctly. So you can have you can put them in a database, you can maintain an Excel sheet, or whatever suits you. You just need to record this traceability from requirement to different parts of your software that you're producing. So a requirement traceability table is also placed at the end of software requirement specification document. So you can have an appendix where you attach this requirement traceability at the end of the SRS document that you're producing. It's always a good idea to have that at the end of your requirements document. So this is a sample requirements traceability matrix where we are saying that we have assigned a unique ID to each requirement. So you can see that a requirement is given an ID of 001, but because you produce lots of different artifacts during a software development life cycle, so maybe 001 is not such a good idea. Maybe you can also say that this you can put an R before it, so you can, or your company might have your own way of assigning unique identifiers of requirements. So this can vary, but this is just an example. You need to have a unique identifier of requirements, and then you have a small description of the requirement, which here says requirements 1, or you can have, for example, you can have get best location, or you can have login. And then you can also have the source. So what is the source of this requirement? So you're saying project objective. In terms of priority, it's written B here, but you can say that the priority is high, or you can say the priority is medium, or priority is low. So this is just giving us information about the requirement. Up at this point, we are not actually tracing it to anything. So what is the test scenario? So the test scenario is that we are going to do a user acceptance. So user would actually see it, and if the user actually accepts it, then we are going to go through it, and whether this test is being verified or not, and what is the status, whether it is approved or not. So this is just an example of one or a possible requirement traceability table or a possible requirement traceability matrix that we can produce. As we said, there can multiple requirement traceability tables. For example, if we want to trace a requirement to my design artifacts, that which requirement is affecting, for example, a very good example is that, or a very good way to introduce, or for you to actually appreciate the benefit of making a requirement traceability matrix is that, for example, let's say we have 3 requirements, R1, R2, R3 in our system, and we make a traceability table. We have all this information which is expressed here, so we say that we also have it somewhere here. But apart from it, we are also making that requirement, so which we are also trying to record that which requirement affect which design artifact. So for example, we have R1 which is directly affecting our architecture design, and we have R2 which is affecting, let's say, class 1, and R3 is affecting class 2. So basically at this stage, let's say we have a change come in, okay, and the client wants a certain feature to be changed. Now, very interesting thing with change request is that normally there are multiple ways of implementing change, and we are going to talk about later on when we discuss requirement volatility in our later lectures. So as I said, that there are normally multiple ways of implementing a change that a client has requested. So for example, this change can be implemented in 2 ways, that either you change R1 or you change R3. Now let's say you have these 2 options. Now there can be 2 possible scenarios, that you have not made a requirement traceability matrix, and you just have a list of requirements R1, R2 and R3, and you know that you can change this requirement by either changing R1 and R3. But if you have not made this requirement traceability table, which actually maps requirements to design artifacts, then you cannot make an intelligent decision. So you would just guess and pick, okay, change R1, and you might end up changing a requirement which is going to affect your whole architecture of the system, which would be very, very costly. So, but if you have made this requirement traceability table, then you would be able to say, okay, no, I will never change my R1, I'm going to freeze it because this is the core of my system and this is going to change the architecture of my whole software. So instead, I will change requirement 3. Okay. And this is what change analysis or change impact analysis is about, that you try to identify that, you try to control the impact of change. Okay, because by changing both the requirements, there is an added cost, but you try to minimize that cost. You try to minimize the impact of change in order to ensure that you complete the product on time within the budget that you set at the beginning of the project. So there are multiple benefits and multiple advantages of a requirement traceability matrix. And another one is that, for example, you are at the final stages of the product and you are conducting those final tests, and you want to see that how many test cases or how many requirements are being tested. So this particular requirement traceability table is very useful for it. As you can see that if we have such a table and we are recording that whether all the changes are approved or not, so if it is written in this final column that all the changes are approved or all the requirements have been approved by the client, then we can safely say, okay, our product is ready to be deployed at the client side. Whereas if you filter all those requirements that are not approved yet, then maybe you need to focus more on that, and you need to see, okay, what are the problems, who was responsible for implementing those requirements and all those things. So there are multiple benefits of making these requirement traceability tables. They will basically help the life of all the software engineers which are involved in the software development life cycle. So let's quickly summarize what we have done in today's lecture. We started our discussion with the negotiation task of requirements engineering process, and then we moved to specification. We also talked about validation, and then we talked about requirements management. So I think it's very important for us to recap the overall requirement engineering process and see where we stand. So this is so we have gone through different requirement engineering tasks. And as I said in all these 3 previous lectures, that we are going to talk about all of these requirement engineering sub processes or all of these requirement engineering tasks in detail, because on their own, Inception is a whole process, Elicitation is a whole process, Elaboration is a whole process, negotiation and so forth, specification, validation, all of these are very detailed processes on its own. So we're going to talk about all of them in detail. We're going to talk about what are the different techniques of doing all these different things. But let's quickly, or let's recap and try to digest what we have done in these previous lectures. So first of all, we have to try to remember that few things that we talked about in the beginning, that requirement engineering or requirements engineering process, it basically consists of these 7 tasks. Okay, and one thing that we said is that they are not sequential. So it's not like waterfall model. So this is not what is happening here, that we complete Inception, then we move to Elicitation, and then when we complete Elicitation, only then we can move to Elaboration, and we can move to negotiation only once we have done Elaboration. So this is not what's happening clearly. So we know that this is wrong. So this is not what's happening. So a better representation is that we say that this is Inception and we are doing Elaboration with it. So if we try to draw it in terms of timeline, so we can say that we are doing Inception and this is maybe day 0 and this is maybe the final day of a project, or the final completion time of a project, or the completion time of producing this SRS document. So we are saying that we have this Inception, we are doing Elaboration at the same time, and we also move to Elicitation, we are doing Elaboration at the same time, we are trying to negotiate some requirements at the same time, and we are doing specification as well, and finally we are validating requirements. And one thing that we said when we discussed requirement and requirements management task, that requirement management task is such that we are going to do it even after we have produced the SRS document. And we will talk about why we do that. So in journal, we start off with inception, and maybe that's the first thing that we set out to do, but we will be doing all these tasks in parallel with each other. So at the same time, when we are eliciting requirements, we might be elaborating some of the requirements, and we might be specifying some of the requirements, and we might be in negotiation with the client about few things. So, and what was Inception about? So in Inception, we said we basically, so what we do is the technique that we deploy when we are at this Inception task is we basically ask set of questions. So it's all about questioning and trying to feel your customer and trying to identify what your client wants. So first thing, or the most important thing, is that you try to identify that who is your client actually. And when we say who is your client, then the meaning is that who is actually the original requester of this particular software, and you ideally want that the requester of the product is somebody in the top management of the client side, because if that is the case, then then normally that's a recipe for success, that if top management is with you, then the project that you are doing, it's going to be implemented somehow, because they actually want it to be done. So you want to identify who is your client. You also want to identify that what is the goal and objective of the client, which he or she they want to meet with this particular software that you're producing. And you also try to come up with the economic benefit that this product is going to give them. And also you try to see that the communication process that you are in with your client, whether it's effective or not. So you also try to evaluate your communication process. And the reason why you do it is that because you want to see that you are at the right level when you are trying to discuss, you're trying to have discussions with the client. And you want to see that whether you are asking right kind of questions, whether you have identified the right kind of people, and whether you're not going overboard and you're trying to ask too many details at the beginning. So Inception is, although it's one of the maybe the most brief task of this overall requirements engineering process, but its importance is very critical. It is very important to successfully do Inception in order to properly elicit requirements. So Inception is clearly very important. So moving on, what was elicitation about? So in elicit, we try to gather requirements. Okay. And when we say we try to gather requirements, what you do is we try to identify the scope. So we try to come up with the bounded scope of our system. Okay. And there are multiple techniques which can be deployed to elicit requirements, and when we discuss our elicitation process, we are going to talk about them. But very briefly, we discussed two techniques. One was collaborative requirement gathering, and this is one of the oldest and one of the most used technique, and it has evolved into very modernized collaborative requirement gathering technique. For example, in the beginning there used to be just big meetings, and people used to sit together. You try to have all the key stakeholders sitting together, and you conduct a meeting. But now there are different ways of doing this collaborative requirement gathering. You have portals now, you have chat rooms now, you do video conferencing, you do lots of these things to conduct this collaborative requirement gathering. But the essence is still the same, that the idea is that you ask all the different stakeholders to sit together, and you try to resolve the conflicts right then and there. You try to come up with good requirements which are consistent and which are not ambiguous for different stakeholders. So one of the techniques that we discussed was CRG, collaborative requirement gathering, and the other one was QFD, quality function deployment. And as I said, that QFD is more used in the engineering domain, but it can also be applied to the to gather software requirements as well. So the goal of elicitation was to gather requirements. So Inception is basically identifying, or you can say relating to your client, and then this is about gathering requirements. And then here comes elaboration. And in elaboration, what we do is we try to understand requirements. Okay, so you can say that elaboration is about understanding the requirements. And as we said, that elaboration is also termed as analysis. So in literature you can also find that in some requirement engineering process, people say that you have elicitation and then you have analysis. So analysis is same as elaboration. So what we do in elaboration is that we try to gain a better understanding of what we have gathered in the elicitation stage, and we can do different kind of modeling. And we said that there can be 4 different kind of modeling that we can do to analyze requirements. So one is scenario based modeling. So what do we do in scenario based modeling? So one is scenario based modeling, the other is class based modeling, then you have this flow oriented modeling, and then you have behavioral modeling. So in scenario modeling we have we can make we try to make different usage scenarios, and there are 2 possible diagrams that you can make when you are making these and when you are trying to do these make these usage scenarios, then you can either make use cases or you can make activity diagrams. Similarly, in the class modeling, what you try to do is you try to identify domain classes. Okay, and you not only try to identify domain classes, but you also try to identify different attributes of those classes, and you also try to identify that how these different classes would interact with each other. Similarly, moving on to the flow oriented modeling, you try to identify the flow of data through your system, because as I said, a computer software can be defined as that it takes some input, it transforms them to a certain output. Okay, and so a software is nothing more than, you know, it's taking some basically I like this definition of computer software, that software is nothing more than that it takes some input data and you have a software and then it produces an output. Okay, and this bit, it needs to be, you know, intelligent and interesting. Okay, so DFDs is another very interesting way of understanding your system, because when you try to see what are the inputs and the output, you do so by identifying what functions are applied to the input data to produce that particular output, and by identifying those functions you gain deeper understanding of the requirements. And another kind of modeling that you do is, which is kind of a step from class modeling, is behavioral modeling, where you can make state diagrams. We discussed a couple of examples that how a state diagram is useful, but what you try to do is you try to identify what are the possible states of the different objects which you have identified in class modeling. So very broadly, what elaboration is about, it's about understanding requirements. So we said inception is identifying or relating to your client, elicitation is gathering requirements, elaboration is understanding requirements. And what negotiation is very simply, you can say it is reconciling requirements, because that is the biggest goal of negotiation, that you try to reconcile requirements in a way that your customer is happy, and you also try to come up with a list of requirements that can be done in the limited resources that are available to you. Okay, and there are a few other things that we do in negotiation. For example, you also try to identify all the risk associated with each requirement. You also try to prioritize your requirement, which is which is very important and very key. For example, in the iterative software development, which we see so often these days happening around us in different software houses. And you also try to roughly estimate that how much cost is associated to a particular requirement, how much time is associated to a particular requirement, and the final objective is that you try to prune some requirements, you try to combine or you try to merge some requirements, you try to come up with a list of requirements which everybody is happy with. So negotiation is about reconciling requirements so all the stakeholders are satisfied. So this is the main goal of negotiation. And then comes specification. So specification goal is to producing an SRS. So you want a document which has the requirements that you have been gathering, you have been analyzing, you have been negotiating. So specifying actually formally produces a work product, and which says, okay, this is what we have gathered so far. And we discussed, we have a separate lecture, we had a separate lecture on requirements document, that what should be an SRS document. And as we said, that there are different templates out there. but as an organization, depending on your context, you need to come up with your own template. But the key when you are documenting requirements is that you need to document requirements in a fashion that they are understandable, they are clear, they are concise, and there should not be too much technical or domain jargon in it, because you have multiple users of an SRS document and you want to write a document which is understandable to all of them. So this was specification that you produce, and you want to produce a final SRS, and then is the validation stage. And validation is about gauging the quality of requirements. So you want to ensure that whatever you have written so far, whatever you have written in the SRS document is of acceptable quality. And when we say we want to gauge quality, then what do we try to evaluate? We try to see that all the requirements should be unambiguous. Okay, all the requirements should be consistent, and if there are any quality standards which are imposed by the client, or your organization has some quality standards, then each requirement should meet that. So, and there are a set of questions that we normally ask when we are validating requirements. So for each, for example, when we are evaluating each requirement, we should ask that whether this requirement helps in achieving the overall objective of the software. So this is one thing that we would want to do, and whether this requirement is not conflicting with any other requirement, or this is not inconsistent with any other requirement, and whether this requirement is quantifiable or not. So validation is that we basically, and what is the technique that is normally deployed when we are validating requirements? So one of the technique is formal technical reviews, where the producer of the software requirement specification document is asked to present the SRS document to the client, to all the other stakeholders, and maybe to the software engineers. And then comes the final requirement engineering task, which is requirements management. And I don't think I need to express it any further, because it says requirements management. But the only important thing to remember about requirement management is that this is a task of requirement engineering process which basically is carried out throughout the software development lifecycle. Because when we are saying we are managing requirements, then we essentially, the key thing here is that we are trying to track and we are trying to control changes in requirements. And that any one of you who has any experience, or who's actually any experience of software development, believe you me that I've been working with industry for a number of years, and lots of software houses, they have problems with managing changes to the requirements, and it happens so often that this is one of the key things why they even start documenting requirements at the first place, because they say, okay, I remember one of the companies, and they had a problem with their client, with in fact their first client, that they were not being able to complete his project, and the reason was that they didn't document it in the first place clearly what the client wanted, and every time they thought that the project is finished, they went to the client and they said, no, I want something else. So in order to ensure that you manage requirements in a better fashion, it is very important that you have done all the other requirement engineering tasks in a proper fashion. If you have not documented requirements properly, if you have not validated requirements properly, you will not be able to track and control changes to the requirements properly. So, and there are different ways of tracking changes and controlling changes or analyzing changes when they come. We discussed that requirement traceability matrix we can make, and there are different kind of requirement traceability tables that can be made to manage requirements in a better fashion. So this is all from our discussion on in-journal requirement engineering process. And as I said, that all these different tasks that we have discussed in our previous 3 lectures, Inception, Elicitation, Elaboration, all these tasks are processes on their own right, and Elicitation, they are big processes. So we are going to have our separate lectures on them. We are going to discuss them as a process, and we are also going to discuss that which tools and techniques can be applied to carry out these processes. So I think that's it from today's lecture. And inshallah, when we meet next time, we will start our discussion on Inception process, and we'll see what technique or what tools can be deployed at the Inception stage, and maybe we will move on to the elicitation process in the same lecture as well. So take care, and Allah Hafiz.